Imagine you're an AI engineer at a movie streaming company, and your task is to build a machine learning model that predicts how much revenue a customer will generate each month based on their viewing habits and their subscription plan. Welcome back to AI Lab 99. This is our fourth project where we'll tackle movie streaming revenue prediction. Our features will include how many hours a customer spends watching each week, their average duration in minutes, and the subscription plan they have chosen, which could be basic, standard, or premium. Using this data, we'll train a regression model to predict their monthly revenue in USD. And unlike our last project, where we handled a binary yes or no feature for accident history using binary encoding, here we'll deal with multi-class categorical data, which is the subscription plans using One Hot Encoding. If you haven't seen the last video yet, be sure to check it out to understand how binary features are processed before continuing with this one. All right, time to fire up the lab. Let's begin. Let's launch the Jupyter Notebook, creating a new notebook. We'll first import Pandas, read our dataset, movie streaming data.csv. This will give us the raw data we'll be working with for this project. Next, let's take a peek at the first few rows using df.head. Here we can see the columns clearly. Time spent in hours per week, which says how many hours a customer spends on this platform. Average watch duration in minutes, which is like the average time they spend per viewing session. Subscription plan, which is either basic or standard or premium. And finally, the monthly revenue in USD, which is the value that we are trying to predict. To get a quick overview of the numerical columns, we'll use df.describe. This gives us the count, mean, standard deviation, and percentiles. For example, on an average, customers spend about 10.5 hours per week watching content with a range from just over 1 hour all the way up to nearly 20 hours. We also see that the average viewing session lasts around 88 minutes. That's more than the length of a typical movie. Finally, the average monthly revenue comes in at about $193, though this number varies quite a bit depending on the subscription plan and how engaged the customer is. Now let's look at the distribution of subscription plans. By executing value counts on the subscription plan column, we can quickly see how many users belong to each category. The output shows that the standard plan is the most popular with 200 users, followed by basic plan with 188 users, and the premium plan with 112 users. Now that we've looked at the raw numbers and the distribution of subscription plans, the next step is to actually visualize the relationships between our features and the target variable, which is monthly revenue. We'll start by looking at the relationship between hours spent and monthly revenue. Let's create a scatter plot for that. On the x-axis, I've placed time spent in hours per week, and on the y-axis, monthly revenue in USD. I've also added a title and the axis label, so the chart is easier to interpret. The result shows a clear upward trend. Customers who spend more hours weekly tend to generate higher monthly revenue. Let's do the same for average duration. This time I'll replace the x-axis with average duration in minutes. The scatter plot shows that as average viewing sessions get longer, the monthly revenue also tends to increase. And this relationship looks even stronger than the hours spent. Finally, let's visualize the revenue across subscription plans. Here, x-axis is subscription plan, which is categorical, and the y-axis is the monthly revenue. We see three distinct clusters: basic on the lower end, standard in the middle, and premium at the top. This makes sense and confirms that the subscription plan is a powerful predictor of revenue. All right, so we have looked at each feature at one time against monthly revenue. But here's a challenge for you. Try creating a 3D scatter plot that combines both numeric features, hours spent per week, and average duration, along with monthly revenue on the third axis. To make it even more insightful, you can color the points by subscription plan. That way, you'll be able to see if the separation between basic, standard, and premium users becomes clearer when you look at all the three dimensions together. Give it a try and see if this visualization gives you a stronger intuition about the data. The code for the 3D plot is also available in the GitHub repo link below. All right, before we train a model, we need to make sure our dataset is in the right format. The numerical features are already fine. but the subscription plan is still text. Since machine learning models cannot work directly with text categories, we need to process this column and turn it into numbers. Let's do that using one hot encoding. I'm using the getDummies function to create a one hot encoding. This generates new columns for each plan, basic, premium, and standard. I've also added the prefix that says plan, so new columns are clearly labeled. And I'm converting them to integers for consistency. When we look at the first few rows, we can see the encoding in action. Each row now has 1 under customer's plan and 0 under the others. For example, the first row belongs to basic plan, so plan underscore basic is 1, while the other two are 0. Next, I'll merge these one hot encoded columns back into our original data frame using the concat function. That way we keep the original features along with the new encoded ones. Now, when we check the dataset again, we see that in addition to the original columns, we have 3 new columns: plan basic, plan premium, and plan standard. Okay, now that our dataset is pre-processed and all features are in numeric form, we are ready to train our model. We'll start by splitting the data into training and test sets. Here I'm creating X, which contains our features, hours spent per week, average watch duration, and 3 one-hot encoded columns. And Y is our target variable, which is monthly revenue in dollars. Next, I'm using the train to split from Scikit-Learn to split the data into train and test sets. I'm keeping 80% for training and 20% for testing, setting the random state as 42 to ensure we get the same split each time we run this code. When I check the shapes, we can see that there are 400 rows in the trained dataset and 100 rows in the test dataset. It's exactly what we'd expect with an 80-20 split from the dataset of 500 rows. Now we can create and fit our model. I'm using Scikit-Learn's linear regression, fitting the model on training data. All right, once that is done, let's try a quick prediction. Here, I've passed in an example. A customer who spends 10 hours weekly has an average watch duration of 100 minutes and is on the basic plan. The model predicts a monthly revenue of $204 for this customer. So, what happened behind the scenes? A linear regression model is learning an equation of this form. Here's what each term means. Y is our target, which is monthly revenue in dollars. X1 is the weekly time spent with a weight W1 that shows how much an extra hour impacts the revenue. X2 is the average watch duration in minutes with its weight W2. X3, X4, and X5 are the one hot encoded plan indicators for basic, standard, and premium plans. Each has its own weight, W3, W4, and W5, which tells us the revenue contribution of the plan compared to the baseline. Finally, we add a bias term B, which acts like a starting point for the prediction when all the other inputs are 0. So essentially, the model is finding the best combination of these weights to minimize the error between predicted revenue and the actual revenue. Let's check the coefficients that our model has learned. Each number here corresponds to the features that we passed in. For weekly time spent, the coefficient is 4.1. That means for each additional hour a customer spends per week, monthly revenue increases by roughly $4. For average watch duration, the coefficient is about 1.5. So each extra minute per viewing session adds about $1.50 to the monthly revenue. For the subscription plans, the numbers show how each plan contributes compared to the baseline. The intercept is about $18, that is the baseline revenue, when all the other features are 0. Think of it as the model's starting point before adding in the effects of time spent, watch duration, and the plan type. To make the model more transparent, let's build a custom prediction function. This will take the equation we discussed earlier and turn it into a Python code. That way, we'll clearly see how the intercept and coefficients come together to calculate the revenue. Defining a function called predict monthly revenue. It takes 3 features: weekly time spent, average duration, and 3 one hot encoded values for basic, standard, and premium. Inside the function, I'm returning the prediction. First, we add the intercept, which is about 18.06. Then we multiply the weekly time spent by its weight, which is around 4.1. That's the effect of an extra hour per week. Next, the average duration multiplied by its weight, which is 1.5. For the subscription plans, we apply their respective coefficients. Notice that the basic plan subtracts about 5.48, while the standard plan adds about 0.79 and the premium adds about 4.68. Let's test this with the same example we used earlier. A customer who spends 10 hours per week watching 100 minutes per session and is on the basic plan. We set the ease plan basic to 1 and the others to 0. And the function gives us about $204, which perfectly matches the prediction from our scikit-learn model. This confirms that our custom function is replicating the model exactly. So what are the insights that we gain from this model? We start with the base revenue of about $18. That's the intercept, which is the prediction when all the features are 0. For weekly time spent, the coefficient is about 4. This means that every additional hour a customer spends per week increases their monthly predicted revenue by around $4. For average watch duration, the coefficient is about 1.5. So each extra minute in a typical viewing session adds about $1.50. Now let's look at the subscription plans. Being on the basic plan actually reduces the predicted revenue by about $5.50 compared to the baseline. The standard plan increases it slightly by about $0.8, while the premium plan almost adds up $4.7. So in summary, heavier usage and higher tier plans push the revenue up, while being on the basic plan has a small negative adjustment. Understanding these weights isn't just a math exercise. As AI engineers, our job goes beyond training the models, where we also need to explain what the results mean for the business. For example, if we present these insights to the stakeholders, they could act by encouraging more user engagement and promoting upgrades from standard to premium. Now let's evaluate this model. We'll use RMSE as it is useful to get an average prediction error in the same units as our target. In this case, it is dollars. Importing mean squared error from scikit-learn. Calculating RMSE for trained data points. Since RMSE is just the square root of MSE, we'll add a power of 0.5 at the end. Let's do the same for the test dataset. Let's print both the results now. So the train RMSE is about 7.97 and the test RMSE is about 8.65. This means that our model's predictions are usually within $8 to $9 of the true revenue. And since the train and test errors are very close, it shows that the model is generalizing well and it is not overfitting. With the model complete, let's now deploy it as a simple Streamlit web application so that anyone can interact with it. I just created a new Python file. We'll first import Streamlit, then we'll add a title for the app and add a short description so users know what the tool does. We'll also create the input fields. The users can enter how many hours they spend weekly and their average duration. The user should also be able to select the subscription plan. The plan gets converted into the one hot encoded values. We'll then add a button. At this point, let's bring our custom prediction function into the app. When the user clicks on predict revenue, the app calls our function and displays the monthly revenue. We'll add this prediction as a success message. All right, now let's run this app, running the command streamlit run app.py. So at the top, we see the title, which says movie streaming revenue predictor. Along with that, a short description of what the app does. We'll provide some input. Let's say this user watches about 10 hours per week, an average duration of 150 minutes on basic plan. Hitting on predict revenue, we see the estimated monthly revenue is around $280. As we keep changing the inputs, the app updates the prediction right away. You can try experimenting with different values. That's the best way to really understand how the model responds to the user behavior and the plan types. All right. With that, we have successfully built and deployed our fourth machine learning project. All the code and dataset are available in the GitHub link below. This was AI Lab 99. Thanks for watching, and until next time, happy coding.